Hey everybody. So yesterday we began the review of the distance and midpoint formula. Something you might want to have handy is that distance and midpoint formula. Wouldn't be a bad idea to have those formulas on an index card or a post-it, or maybe written on a bulletin board, just somewhere accessible, because we are going to be using it. Just like yesterday, we are going to use those formulas several times today. And as the title of this lesson says, we're going to be applying it in a couple different examples. So for example 1a, the question is the point P in the interior, exterior, or on the circle? This is a pretty common question in geometry. Now, I don't need to go ahead and graph the circle or anything like that. I can actually verify where this point is in location and how it relates to the circle algebraically. So let's kind of break down this question a little bit. Let's first look at the equation of the circle. From that equation, we can see that the center is at -1, 0, and the radius is 3. If you're not sure how I'm coming up with that, you might want to go back and review the equation of a circle notes. Now, knowing the radius and knowing the center, what this question is really asking us is, this point, how far away is it from the center? The radius represents the distance from the center of a circle to any point on the circle. So really, if I can find the distance of point P to the center, I can compare that to the radius. So let's see what that looks like. Setting up our distance formula that we covered yesterday. If I complete my distance formula, I would get the distance from P to the center of the circle is radical 13. And if you weren't sure what that equals, that's approximately 3.6. So let's think about what this means. That means that this point, P, is 3.6 units away from the center. Well, think about what that relates to the radius. 3.6 is bigger than the radius. Therefore, if P has a distance that is greater than the radius, P is outside the circle. And we label that as the exterior of the circle. P is on the exterior of the circle, or outside the circle. If the distance between a point and the center of the circle is smaller than the radius, that point would be on the interior of the circle. And if the radius and the distance are exactly the same, then that means that point is on the circle. Let's look at another circle example. It says, what is the radius of a circle that has a center at -2,5 and point B is on the circle 1,9? Well, again, the radius is the distance from the center to any point on the circle. Well, B is on the circle. So we really just need to apply the distance formula again. I'm not really reviewing the distance formula because that was yesterday's examples. So you might want to go back and review those notes and video if you're not sure why I'm setting up that equation that way. D does represent distance in this case. And we get D equals 5. That would mean the radius is 5. The distance from a point on the circle to the center is represented by the radius. Okay? By all means, as we proceed through this video, feel free to pause the video, try to do some of the calculations on your own, then hit play to see if your calculations match mine. Now, the next two examples, I'm not going to do the calculations for you, but here are the answers. Point A is on the exterior of the circle, and point A in the second example is on the interior. Feel free, go ahead and do the calculations and see if your answers are verified with this solution. Moving on to page 2. This problem gives us several different steps to complete. We know two endpoints on the diameter of a circle. Picture what the diameter is that line that runs through the center of the circle and has endpoints on the edge on the circle itself. We want to be able to determine the center, then the radius, and then lastly the equation of the circle. So in order to do that, we can calculate the midpoint of A and B to determine if the center, or what the center is of that value. So the midpoint formula, I'm going to do negative 7 plus 1 over 2. That's the midpoint of my x coordinates. And negative 1 plus 5 over 2, that's the midpoint of my y coordinates. If we simplify and solve, we would find that the center is at negative 3, 2. To figure out the radius, there's two ways we can solve the radius. We can find the distance from the center to one of our original endpoints, or we can find the distance of the diameter and then divide by 2, because then that would be the distance, or because the radius is half of the diameter. So let's do it that way. Let's find the length of AB, and then we'll divide by 2, because AB is the diameter, radius is half the diameter. So the distance for AB looks something like this. And we get distance equals the square root of 100. And feel free to pause this video and do the calculations on your own. I don't want this video to be half hour long for you guys. So feel free to pause and do them on your own. We get the distance is 10. That's the length of the diameter. Therefore, the length of the radius is 5. Remember, radius is half the diameter. Now, we wanted to write the equation of a circle. Now we put this all together. The equation of the circle, remember, it's x minus the x coordinate. If it's minus negative 3, we change that to a positive 3. X minus negative 3. That double negative becomes a positive. Plus y minus that y coordinate of the center. And it equals the radius squared. So notice we're putting 25 out there. That's the radius squared. This is the equation of the circle. Okay? The next example I'm leaving again as an optional problem for you guys to try. But here's the answer to the next problem. Feel free to do the calculations and see, does your calculation for this problem match my solution here of the center being 5, 6, radius of 5, and our equation of the circle. Let's check out our last couple examples now. I have some part of this written out, so I'm covering that up. The question is triangle ABC an isosceles triangle given these 3 coordinates? Well, to determine if something is an isosceles triangle, first let's review the definition of isosceles. Isosceles means that 2 of the legs of the triangle, or 2 sides of the triangle, have the same unit of measurement, right? Or the same length, I should say. So, we could try to figure out what is the length of AB, the length of BC, and lastly, the length of AC. And we can compare those lengths. Now, I have the calculations underneath these pink Post-its. So if you want to pause, try to do the calculation on your own, and then hit play, now would be a good time to do so. The distance, or the length of AB, is 5. The length of BC was 5 radical 2, and the length of AC was 5. We can see that 2 of the sides of the triangles do have an equal length. Therefore, yes, this triangle is an isosceles triangle. Now, if we want to proceed and look at our next example about what is the diameter of a circle with radius CD, and C is the point 3, 4, and D is the point 8, 16. Well, first I can find the length of the radius. So we can figure out what does CD equal. Well, that length is the distance from C to D. Calculating this value, right, we would get 5 squared, 8 minus 3 is 5, 5 squared is 25. 16 minus 4 is 12, 12 squared is 144. and we get 169, or 13. That's the length of the radius. Well, we want to again recall our relationship between radius and diameter. Our relationship between radius and diameter is that the radius is half the diameter. So if this is the radius, that would imply that our diameter is 26. And I'll just put units right now. When we don't have inches, centimeters, or anything like that, we can just label as units. Our very last example asks us, similar to problem 4, is to determine if ABC is an equilateral triangle. I went ahead and plotted these points. What you're going to want to do for problem 5 is determine the length of AB, the length of BC, and the length of AC, and see if we can determine if it is an equilateral triangle. Well, to determine if it's an equilateral triangle, let's find the length of each of the 3 sides. If all 3 sides are the same, then yes, it is an equilateral triangle. Kind of looks equilateral, but let's verify algebraically. If we want to calculate the length of AB, and we're going to use the coordinates of A and B to calculate this. This would be a good time to stop and pause because I'm really just writing out the solutions. I'll get radical 17 for the length of AB. I'm not going to go into decimals. We'll leave that as an exact answer for now. If I calculate the length of BC, I would get now, already I can see that no, this will not be an equilateral triangle because I already have 2 different side lengths. Now, this triangle, we can actually go ahead and I'll write this out as well. We can go ahead and calculate AC just for the sake of completing this problem. But we already know that it is not equilateral because if it was equilateral, it would have equal side lengths. We can see that 2 of the sides have the same measurement, so it is not an equilateral triangle, but rather an isosceles triangle. Today's practice problems for you guys to complete employ some different examples of using this midpoint and distance formula. It will not always be, hey, find the distance between these 2 points. It's usually mixed into the context of another problem. So yes, all we did here was find the distance. But there was a purpose. We were applying the distance formula to determine if the triangle was equilateral, what the diameter was, if the triangle was isosceles. So we're applying these formulas in the context of other geometric problems. Take your time on the homework today. If you guys have any questions, please feel free to reach out to me. We can email, go back and forth to Google Classroom, or we can do a Zoom conference with a group of students or individually. All right? Good luck with the problems, guys. Let me know if you need any help.